Alright, this is IBSL Maths May 2015, Paper 1 Time Zone 2, Question 4. Here we go. Let g equal the natural log of x divided by x. Find g dash of x. Okay, this shouldn't be too bad at all. First thing we've got to notice here is what have we got? We've got a quotient. So let's go ahead and use our quotient rule. Let u equal ln x. And v equal x. U dash is going to be 1 over x. V dash is going to be 1. And v squared is going to equal x squared. So, using all that information, we are going to have g dash of x. Remember to get these in the right order. U dash v minus uv dash divided by v squared. So we got that far. Fill in the blanks, write down your answer. It should be pretty easy. We can see we're going to have nice things that cancel with each other. Let's see how we go. U dash, so it's 1 over x multiplied by x minus ln x, and v dash was 1 multiplied by 1. All divided by v squared, which is going to be x squared. So what have we got? We have x by 1 over x, which is just 1, minus the natural log of x, all divided by x squared. Go back and make sure we've just got our nice working there. I know you're not marked on it, but as I keep reminding you, try and, well, that didn't quite fulfill what I was going to say. You try and make it easier for them. So, you know, underlining your answer, probably highlighting it or doing something in a different color would be even easier. There you go. It's labelled. We know what it is. Let's just, you know, put a line across, get on to B. But again, make it easy for the marker to give you the marks. That's always in your best interest. Find the integral of g of x dx. So now we want to integrate, and I've lost where my, there it is. Integral of g of x is going to be the integral of ln x divided by x dx. Great. Few ways you can tackle these ones. Let's have a think about what we might want to do. Let's try a bit of substitution here. I'm going to let u equal the natural log of x. Therefore, du dx, the derivative of the natural log of x, is 1 over x. And you can see here we're going to end up with what we want. Now, again, there's lots of ways you can substitute it in. You can just replace the 1 over x with du dx and cancel it out. So you end up with, eventually, whichever way you want to do it, you're going to end up with the integral ln x we're going to call u of u. 1 over x we're going to call du dx. And then that's multiplied by dx. And you can see the dx is cancelled there. So we've just got the integral of u du. Well, that's going to be u squared divided by 2 plus c, which of course we then need to go back and substitute in what u actually was. So the integral of ln x over x is actually the natural log of x squared divided by 2 plus c. Now I'll just go back quickly to, if you didn't quite follow how I did that substitution, when I go over here, probably the safest way, the easiest way to make sure you don't mess it up. Here I've got du dx. Let's turn that into dx du. So I'm finding the reciprocal, so the reciprocal on the other side will be the same. So that's just x, because x over 1, I don't need to write the 1. Now I want to replace dx, so I could just replace dx with x times du. So therefore I'm going to have the integral of ln x over x dx is going to be ln x over x, and I replace the dx with x du. You can see here the x's cancel, and of course ln x, I probably should have just written it in the first way there. ln x is just the same as u. So what we really end up with there is the integral of u du, and then we just proceed exactly as we did before. Either one of those ways is fine. Make the substitution, go ahead and do it. If you didn't want to do substitution, could you do that one another way? I like to give you options. Let's have one last look. If I was doing the integral of ln x over x dx, what am I thinking? I'm thinking that the natural log of x, how does that turn up? It doesn't really turn up, does it? Does it ever come from anything? No, so it must have come from having ln x in brackets. And if I squared that, then when I did the derivative using my chain rule, I'd have 2 ln x multiplied by the derivative of that. I can see a 1 over x there. I know that the 1 over x is going to turn up. So let's just experiment and see. And then you do a little bit of thinking and say, well, if I differentiated that, let's do our checking. I'd have 2 ln x to the power of 1 multiplied by the derivative of the inside brackets, which is 1 on x. And you go, well, hey, that's almost exactly what I've got in this expression, isn't it? The only thing is I'm supposed to have a 2 there. So what would compensate? What would get rid of that 2? Dividing by 2. So this one would need to be divided by 2 plus c. And you can get to your answer, or at least check your answer very quickly. Probably the first way is easier for most of you. Go with that. But don't be afraid to have a crack. If you find yourself scratching your brain a little bit in the exam, have a go. See what you can come up with. See you in the next one, guys.